right, number 1. Reflectional, yes. How many? 4. 1, 2. You can go diagonal. 3, 4. Rotational, yes. And the degrees are 90, 180, and of course 270, the ones that we are used to. Number 2, reflectional, yes. How many? Only 1. Sorry, that was a bad line. Rotational, no. Reflectional, no. Rotational, no. So these are not applicable. Reflectional, yes. How many? 4. 1, 2, 3, 4. Are there more than that? Just kidding, not 4, 8. So 4, 5, 6, 7, 8. That's much better. Rotational, yes, and there's lots of these. 45, 90, 135. I'm going to write dot, dot, dot. 315 would have been the last one that you write. Those are the degrees of rotation. Okay. Number 5, reflectional, no. Rotational, no. Number 6, reflectional, yes. How many? Infinite. Rotational, yes. Degrees, also infinite. Moving on to the back. Reflectional, yes, and I get just 1. Rotational, no. Reflectional, yes, 6. Rotational, yes. These would be in increments of 60. There's all of them. All right, this one's unique. Number 9, reflectional, no, but rotational, yes. And the degrees are 120 and 240. All right, this was, I got false, false, false. Did you get false, false, false? So I got 10A, a counterexample could be number 9. 10B, a counterexample could be number 7. And 10C, it could also be number 7. I was trying to pick ones that were on this side of the page so we could see them and talk about them. So let's look at number 9. You were saying you're confused about how to find the types of symmetry. So first, you want to know if it has reflectional / line symmetry. Really, you just have to play with the figure. You just have to draw some lines, and you look at the left and you look at the right, and you see if they're identical twins. So you can draw yourself a line here. You look at the left and the right. Are they identical twins? No. Draw another line, maybe right here. Is the left twins with the right? Like, if I were to fold that, would it land on top of itself to where you couldn't even see the original one anymore? No. So, to find reflectional symmetry, you have to start drawing some lines and looking at one side of the line and the other side. Picture yourself folding the paper. Pick up the paper, actually fold it, and hold it up to the light. That's allowed, okay? Now, rotational, you need to picture that you are taking your paper and you are turning it. So if I had not a line now, if I had a dot, and I took that figure and I turned it to where this star landed on this star, I turned the whole figure, would it look the same as it started? If I turned that and the star landed on the star, it would look the same as it started. It has rotational symmetry. How do you find the degrees? That's the easy part. You always take 360 and you divide it by the number of parts it has. Like this one has 3 parts, 3 little stars. So in this one I divided it by 3 and I got 120. And then the next one would be 120 times 2. And the next one would be 120 times 3. How do I know how many degrees are on number 8? I take my 360 and I divide it by how many vertices there are. Since there's 6 vertices, it's a hexagon. That's why I got 60. And then you just do 60 times 1, 60 times 2, 60 times 3, all the way until you get to 360. Dilation homework answers. I did send these out on my Remind, but I want them to be on the recorded lesson, okay? So is everyone okay with that? We found a typo on that one. number 16i should be 4, negative 8. Good catch, Aaliyah, thank you. Okay, number 2. So number 2, when we're looking at the snowflake one, we know the scale factor is always second over first. Second over first. So we're going to take a value from the second one and put it over a value from the first one. How do I know which one is first and second? They have the primes. Alright, so I'm going to take a value from the A prime, and I'm going to put it over the corresponding value from A. So we're just going to get 4. If we had done 8 over 2, we would have also gotten 4. Alright, so if we have a figure and we have a center of dilation, and we want to dilate that figure, we need a ruler, and we need to connect the dots. That's how we always start these, connect the dots. So I'm going to connect O to X. I'm going to connect O to Y. I'm going to connect O to Z. I'm going to connect O to W. You do this with a ruler. You do not do it freehand like I'm doing on Smartboard. Then you measure. You measure the distance from O to X. You can do that with a ruler, or you could even do that with a compass, which would be a lot more geometrical, a lot more sophisticated of a way to do it. So if I did do it with a compass, I would like measure from here to here, and I'd measure from here to here, and I'd put an arc. And then I'd open my compass from W to O, and then I'd move it over and put an arc. And then open my compass from O to Y and move it over and put an arc. And then open my compass from O to Z and move it over and put an arc. Once I have doubled that length, once I have cloned that segment, then I can connect the dots, and that's my X prime, Y prime, Z prime, W prime. So the scale factor is 1/3, and you measure this, and let's say it's 9 centimeters. Then you have to take that number, whatever it is, and you have to divide it by 3, and then I'm going to measure only 3 centimeters. 3 centimeters. And then over here, I'm just going to measure 3 centimeters, and then I'm going to connect them. I've got A prime, Z prime. Okay, Kendra, I promised you I'd write the reflection rules down. Everybody else, I also promised you I would teach you a way to memorize the rotation rules. So I'm going to show you that real quick as well. Let's start with XY. The trick to coming up with all 3 rotation rules at once is you only have to remember one thing. You have to remember switch and make the first one negative. Say that out loud. Switch and make the first one negative. Switch and make the first one negative. Switch and make the first one negative. So we're going to do exactly what we said. We are going to switch and make the first one negative. Now I'm going to switch and make the first one negative. Now I'm going to switch and make the first one negative. That is your 90, your 180, and your 270-degree rules. You see that? So you can come up with all of them by remembering that one chant. All right? Let me remind you of the reflection rules. If you want to reflect over the x-axis, oops, that's a negative. You negate the y. If you want to reflect over the y-axis, you negate the x. If you want to reflect over y equals x, you do Freaky Friday, they trade places. And y equals negative x, they trade places, but they also become negative. All right, here's some practice. Name the rule for the transformation that occurs in the picture below. So this is obviously a reflection. And it's a reflection over the y-axis. So we know the rule, when it says name the rule, we know reflecting over the y means change the x. That's the rule. Describe the transformation. All right, the +7 means right 7. And the -4 means down 4. That was really ugly. Okay? If you reflect rectangle ABCD over the x-axis, what will be the coordinate point of D prime? So D is at 2, 3. So if I want to reflect over the x-axis, I change the y to -3. D prime. What transformations are present below? This happened in your assessment. It looks like it's a reflection, and then it's a translation to the right 2. So that's called a composition, 2 transformations in 1. A figure rotates 150 degrees clockwise. How many degrees has it rotated? Counterclockwise. We know when we rotate full circle, it's 360 degrees. Good, so we're just going to subtract from 360 to get 210 degrees. Rotate negative 711, 270 degrees. So first thing I'm going to do, well, if I'm the student, I'm going to, at the top of my quiz, I'm going to write all the rotation rules. Not from my notes, but from my memory. I'm going to write them all at the top, and then I'll have them to use. So I'll be able to see the rule right in front of me. There's the rule. Okay, it says take Y and leave it alone. Take Y and leave it alone. Take X and change the sign. Take X and change the sign. Okay, let's do 2 more. 180 degrees. Here's the rule. You're just moving 180 degrees, so both signs are going to change. You're going to be diagonal on the coordinate plane. So change that sign, oops, and change that sign. Last one, 90 degrees. I'm writing the rule down next to my problem. Take Y and change the sign. I took Y and I changed the sign. Take X and leave it alone. Don't touch it. Keep it how it is. Okay. So you may begin your quiz.